Hello, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1, Class 2 ISAS 2. Today, we will present the algorithm that is depth first search. My name is David Julian Ernestine.
Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Muhammad Rafialia and I'm from the first group.
Hello, my name is Isak Didon Simamora. I'm from Group 1 and I'm from Class 2 ISAS 2.
Chapter 1, Introduction. First, background. The ability of an expert system is obtained through the implementation of algorithm and is thus determined by its performance. There are several algorithms that can be implemented in an expert system that affects the ability of the expert system is the solution. One of them is the DFS algorithm. The DFS algorithm performs a search to reach the depth of the space. When the way to reach the solution is long, the DFS algorithm doesn't waste time searching for many states. Also, for multi-branch search space, the DFS algorithm is much more efficient because it does not have evaluate all nodes. With an every system problem, solution care found based on existing symptom. So, the DFS algorithm can be used find is a solution in one search. Therefore, this final project will analyze how the performance of the DFS algorithm is on an expert system. The case study used in implementation is an expert system for diagnose lung disease. Parameter or measures of the algorithm performance to be examined are completeness, time, complexity, space scope, and optimality. Chapter 2.
Definition of depth first search. Depth first search, or DFS, is an algorithm for traversing or searching the data structure of a tree or graph. The algorithm starts at the root node. Select any node as the root node for the graph and explore as much as possible along each branch before tracing back. The word backtrack here means to find a node that traverses back along the same path if it's moving forward and there are no more nodes along the current path. All nodes on the current path are visited until all unvisited nodes are traversed, after which the next path is selected. This recursive nature of DFS can be implemented using the stack. The basic idea is as follows. History of depth first search. A version of depth first search was first investigated as a maze-solving strategy by the French mathematician Charles-Pierre Tremox in the 19th century. His algorithm required drawing a line on the ground to mark the path until a dead end was reached or an exit was found. The path has not been visited unmarked, has been marked once, or has been marked multiple times. Initially, if there are multiple, a random direction will be selected. When you arrive at a split junction that you haven't visited yet or marked, select an unmarked random direction and mark the path. If you arrive at the marked junction and the current path is marked only once, turn around and mark the path twice. If not, select the direction with the fewest marks and mark it again. When you reach the exit or solution, a path with only one marker points to direct route back to the starting point. If there is no exit, the method returns to the beginning and all paths are marked multiple times. This is the application. First, detecting cycle in a graph. Second, path finding. Third, topological sorting. Fourth, to test if a graph is bipartite. Fifth, finding strongly connected component of a graph. The last one is solving puzzle with the only one solution. Explanation of depth first search. The depth first search of DFS algorithm traverse or explore data structures such as trees and graphs. The algorithm starts at the root node. In case of a graph, you can use any random node as the root node, and examines each branch as far as possible before backtracing. When a dead end occurs in any iteration, the depth first search or DFS method traverses a network in a depth-hard motion and uses a stack data structure to acquire the next vertex to start a search. Thank you.
And now the advantage of EDDFS is the first one is EDDFS give us the hope to find the solution if the exists in the tree. And the second is when the solution are found at the lower depths, say n, then the algorithm prove to be efficient and in time. And the third, the great advantage of EDDFS is found in game trees. Searching where the EDDFS search operation tries to improve the depth definition, heuristic, and score of the searching nodes so as to enable efficient in the search algorithm. And the fourth, another major advantage of the EDFS algorithm is its quick responsive. The early result indicates are plus point in the algorithm. The followed up with multiple refinement after the individual iteration is complete. And next, took the work is done here is more, yet the performance of EDDFS is better than single BFS and DFS operation exclusive. And the sixth, space and time complex are expressed as O, and here O is defined as goal deep. And the last advantage is the EDDFS let us consider the runtime. Let's say B lebih besar I, where B is branching factor and I is the depth limit. Then next we search the goal node under the bound K. On the depth K, we say there may be BK nodes that are only generate once. Similar, the node at the deep limit K min 1 is twice, then thrice for K min 2. And the node is generate deep in I as K times. And the disadvantage is the first disadvantage, the time taken is exponential to reach the goal node. And the main problem with EDDFS is the time and was calculation take place at each depth. And the third disadvantage is the situation is not as bad as we may think of, especially when the branching factor is found to be high. And the last disadvantage is the IDDFS might fall when the BFS fall. And when we are find multiple answer from IDDFS, it give back the success node and its path once, even if it needed to be found again after multiple iteration to the stop the depth bound is not increased further. And the conclusion we have is iteref depend depth first search or IDDFS is hybrid algorithm that evolved from BFS and DFS. IDDFS may not be used directly in many computer science algorithm application, but the strategy is used to retrieve data in infinite space by increasing the depth limit with iteration progress. This is very convenient and has application in the AI and emergency data science studies. And for the suggestion, from the discussion about this ISAS project, the author hope the readers will know more about DFS, depth first search, and BFS, breadth first search, and be able to implementing in the real life.
So many of us present the DFS algorithm. Lack of sorry. Assalamualaikum warahmatullahi wabarakatuh.